Hi everyone, welcome back to my channel. I'm Estefania and it's great to have you here. If your goal is to learn Python, then this course is for you. You will learn all the fundamental concepts of Python. We will start by installing Python and installing Visual Studio Code, a code editor that is super powerful and used by developers every day. This is a tool where you will write and run your code. Then we will dive into variables, data types, strings, user input, operators, comments, lists, tuples and dictionaries, conditionals, for loops and while loops, functions, and finally you will learn how to browse and read the Python documentation. You can find all the timestamps in the video description below. I also included a link to a GitHub repository where you can find all the code that you will see during the course. Are you ready? Let's begin! The first thing that you need to do to start working with Python is to go to the official website, python.org. From there, you can go here to the Downloads tab and choose a download that applies for your operating system. In my case, I'm using a Windows computer, and this is the latest version at the moment. You can also choose to install it for macOS or for other platforms. I'm gonna choose Windows. Right here, you click on it, and then you will see that the download starts right here at the bottom. You'll have to wait a few seconds or perhaps a few minutes depending on the speed of your internet connection. When the download stops, you can show that executable file in a folder, show in folder. You will see this executable file with the version that you downloaded. After you do that, you click on the installer and you will see this right here. In my case, I already have Python installed, so it prompts me to upgrade my current installation to Python 3.10.6. But in your case, it will ask you to install Python. So let's upgrade it now. While you install it, you will see some settings. It's very important that you choose Add to Path. That's super important because that will give you access to the Python command that you can use in the command line. Right now it's installing. You will need to wait like a few seconds or minutes depending on whether you're installing it or upgrading it. And after that, you should see a confirmation message. And voila, right here we can see that the setup was successful. So I would just click here on close and finish the installation process. Awesome, now you have Python installed. So the next step is to install Visual Studio Code. That is exactly what we will do in the next video. But before we do that, let's check our current version of Python. In the command prompt, let's open the command prompt by going to search, then writing command, and then clicking on command prompt. Let's open this in full screen. And right here, we can check our version of Python by writing python -- version. And that will show us our current version of Python. Awesome, right? If this command works, then everything was set up correctly. If you see an error, then you might have to troubleshoot something that happened during the installation, like not adding Python to the path. That is very, very important, okay? To be able to use this command in the command prompt. But if everything worked correctly, then you're ready to go and you can continue the course. So let's go to the next part of the course where we will install Visual Studio Code. I will see you there. Great, so now we're going to download Visual Studio Code. If you already have it installed, please feel free to skip this section. To download Visual Studio Code, go to code.visualstudio.com. We can close the Python tab now. Go to code.visualstudio.com. And there you will see a very visible button prompting you to download Visual Studio Code for Windows. You can also download it for other platforms, and if you're working on a Mac, then you will see the option to download Visual Studio Code for Mac automatically. You can choose different versions here. The Insider's version is like a really updated version of Visual Studio Code with the latest features. And the stable version has the features that have already been tested, so I recommend installing the stable version. You have that for Mac, for Windows, and for Linux. Click on the arrow or click here on the main button, and you will see the screen. Thanks for downloading VS Code for Windows. Awesome, right? If the download doesn't start, then you can click this direct download link. And you will see the download starting right here below. It may take a few seconds or a few minutes depending on your internet connection, but the download will eventually be completed. Visual Studio Code is a lightweight and powerful source code editor. So basically we're going to use it as our main tool to write and run our code. Great, so now I have my executable file right here, my installer. To install it, I just need to double click on the file, like this, and then the first thing that you can see is the license agreement. Read this and then accept the agreement. Next, you have additional tasks like creating a desktop icon, and you have other tasks. It's very important too that you add this to your path, because it can be helpful later on if you want to work with a command line and Visual Studio Code, like if you want to open a file in Visual Studio Code from the command line. Always make sure that you check this, and you can also register this code editor as an editor for supported file types. Okay, and you can also create a desktop icon. I usually like to have this on my desktop. Then click Next, ready to install. Click Install to continue the installation, or click back if you want to review or change any settings. Okay, then you click on Install, and from there the process should be very straightforward. After you complete the installation, you will see the icon. You should have a desktop icon because we selected this option. Double click on that and you will see the initial Visual Studio Code window. I already have it installed, so let's go to VS Code. I will cancel the installation and I will open Visual Studio Code. This is one of the most powerful, helpful, and amazing code editors that you can find in the developer community. We will be working with Visual Studio Code during the course, and you will learn how to do the basic things like creating a file, a folder, and different functionality that you can use. Great, so now you have Visual Studio Code and Python installed. Awesome! When you open Visual Studio Code for the first time, you may see a window here in the main panel of the code editor with different options and articles from Visual Studio Code. If you see that, just click on the X to close it. It should be right here on a little tab. So after we have that, now we can use Visual Studio Code, particularly the Explorer. If you click here on the sidebar, you can see that we currently don't have a folder open. We will create a folder for the course where we will keep our Python file. I already created that folder. It's in my documents and I named it Python YouTube Course. To open that folder, I go to File, then I select Open Folder. I find my folder, Python YouTube Course, and then once I'm inside the folder and I see the name of the folder right here, I click on Select Folder. Great! This will ask you if you trust the authors of the file in this folder. Of course you trust the author of the files because that will be you. So click here, yes, I trust the authors, and that will enable all the features of Visual Studio Code. After the folder is opened, you will see the name of the folder right here at the top and here in the Explorer. And this panel will be initially empty because currently it doesn't have a file. But if we right-click on it and we select New File, we can create a new Python file. To create this file, we just need to give it a name, like program, or script, or app, any name that you think could be descriptive for your particular program. And then we write the extension .py. .py is the extension that we use to create a Python file. If we write that and then we press enter, we will see our Python file opened in the code editor. And if you go to that file in your File Explorer, you will see it there too. So that's really cool. You've just created your first Python file, so congratulations! Since we have our first Python file, we can run our first Hello World program. A Hello World program is a program that prints Hello World. That is a tradition in the developer community, because it just takes one line of code, usually. So let's do it. In Python, to show Hello World in the command line, we just write print, and then within quotation marks, we write the text that we want to show, Hello World. Then we save the file. If we make some change in the file, we will see a white circle right here instead of an X. That is telling us that we have unsaved changes in our file. So to save those changes, we can use the keyboard shortcut Ctrl+S, and that will replace the white circle with a little X right here. Let's open the terminal, where we will have our command line. To open the terminal, we can use the keyboard shortcut Ctrl and the backtick, and we will see the terminal. If you've never worked with the terminal before, that's totally okay. I will show you how to do that step by step. Basically, what you can see right here is like an introduction to the tool that you are using, Windows PowerShell, and this is the path to the folder that you currently have opened. This is where you will run all the commands that you will write right here on this side of the angle bracket. This path will be assigned automatically in the terminal if you have your folder opened in Visual Studio Code. So you can see that this is the same name of the folder that we have right here, Python YouTube course. If we run a command right here, if we write something like Python here, that command will be executed within this folder on that particular path. Great, so don't be afraid to use the terminal. It's a really awesome tool. Once we have the terminal ready and we are inside PowerShell, to run our program we just need to write Python, which is the command. Remember that we added Python to path to have access to this command in the command line. And then we write the name of the Python file that we want to run. In this case, program.py. Then we press enter, and voila, we see Hello World right here. Exactly what we wrote within the quotes. Great! It's time to celebrate because you just wrote your first Hello World program in Python, a tradition in the developer community. Great work! Okay, so now that we have that ready, we can start talking about our first main concept in programming, variables. So let's close the terminal. We can kill the terminal and delete all its previous commands and output by clicking here on the trash can. This option is Kill Terminal. It basically deletes everything that you ran previously in that particular terminal. So if you open it again with Ctrl and the backtick, you don't see that history of commands and outputs that you ran previously. Okay, so let's kill the terminal for now, and let's delete our line of code and save the file with Ctrl+S. You can also use the options from this menu. To save, you can go to File and Save. But of course, the keyboard shortcuts will save you a lot of time while you're coding. Okay, so let's start talking about variables. What is a variable? A variable is a name that we assign to a particular value. For example, let's say that I want to store my name in a variable. I want to store it so I can use it later on in my program. Because when you just write a particular value in a programming language like this, 56 or hello, that value will not be stored. And you will not be able to use it in your program anymore, just on that particular line. If you want to store it and use it multiple times throughout the code and have the possibility to update it, then you need a variable. They act like containers. When you create a variable, that variable has a particular place in memory where that value will be stored, and every time that you use that particular name, you will be able to access the value. So let's see this concept in action. Let's say that I want to store the name Stefania. You can write your name right here, and I want to store it in the variable called name. Every time that I use this particular name, this particular variable, I will be accessing this value. So let's use print, which is a function, to do something in our code. And we are going to print or show in the terminal that particular name, the value of that variable. Let's see what we get. If you open the terminal again and you press the up arrow key, you will get the last command that you executed, that you ran. So that's super helpful too to save you some time. Or you can write the command again. That's totally okay. If you press enter, you will see the output. But the output is the value of that variable. We don't see name literally right here. We see Stefania. And you should see your name printed here. So variables are like containers. We assign them a particular name, and that name should be descriptive of what they represent. For example, I would not assign the name color to this value because it doesn't represent a color. It represents a name. So that's super important too. That is a best practice in programming, assigning descriptive variable names. There are some rules that you should follow when you write variable names. First, a variable name must start with a letter or an underscore. Usually, they start with a letter and underscores are used for specific purposes. Then, a variable name cannot start with a number. So you can't write something like this, okay? You will see an error. So we see an error because Python is not really detecting that this is a variable name because it breaks the rules. Those errors in how we write the code are called syntax errors. The syntax is how we write a program in a particular programming language, like all the rules that you have to follow for the program to run correctly. Great, so now we have this, and the program is working again. Let's save it. Another rule is that a variable name can only contain alphanumeric characters and underscores. So a variable name can only have these characters. Letters, uppercase and lowercase letters from A to Z, so they would be like this. They can also contain numbers, but they cannot start with a number. But they can have a number in between, like, for example, name 1, that would be valid too. Name 5, you can also have numbers in the middle, but that's not so common. It's usually recommended to write descriptive variable names and names that are easy to read. And you can also use underscores. Actually, that's the recommended way to separate different words in a variable name. Like, for example, if I have a variable, my name, since these are two different words, I would separate them with an underscore and write the entire variable name in lowercase. That's another naming convention in Python. This naming style is called a snake case. There are several different ways to separate words in variable names, and every programming language has different conventions, different agreements among the developer community on what is the best way to write them. Some programming languages separate words with a hyphen that is called kebab case. Some of them separate them with an underscore, snake case, and some of them, like JavaScript, separate them with an uppercase letter that is called camel case. In Python, we use a snake case. And another key thing about variables is that they are case sensitive. So if we write this variable in uppercase, and then we try to use it in our program in lowercase, like this, it will not work. We see that name is not defined. Why? Because the variable is not defined in the program. Here we used uppercase letters, and we have to write it in exactly the same way as we defined it. Let's undo that, and now the program is working again. Great! Now, a variable can be updated. We don't have to have a particular fixed value for that variable. Once we create the variable in memory, we can update its value. So if I want to change the name during the execution of the program, for some reason, to Nora, I can do that. And then from that point forward, while I run the program, the variable name will now refer to the value Nora. So let's check this. Let's print name again. We are defining the variable initially with the value Stefania. Then we are printing it. And then we are updating it. And then we are printing it again. So let's see. If we open the terminal and we run the program again, we can see the output, Stefania, and then Nora. We are using the same variable. As you can see right here, we are using the same variable, but right here we are updating its value. So you can see that the variable is more like a container or a box in memory, where we can store values and we can update them. And the variables do not have to have a particular type of value. Here we are storing a value that is like text. It's called a string in programming, and we will see much more about strings during the course. But right here we could update it to a number. Usually we don't do that because it really depends on what we need, and usually we keep that particular data type. But it is possible, like this. We change from a string, text, to a number. That's possible, but usually we don't do this because usually if a name is represented by text, then updating the name should also be represented by text. But it is possible. Great, let's see another example. Let's define a variable called favorite game. If you click here on the Explorer, you can close this while we don't need to use the Explorer. Okay? Let's say that my favorite game is Super Mario Bros. I'm going to show the value of this variable and then I am going to update it to Pac-Man. Try to predict the output. What do you think will be the output of this program? First, we are assigning this text, Super Mario Bros, to the variable favorite game. And then we are printing it. And then we are updating the value to Pac-Man. And we are printing it again. Let's open the terminal. And now let's run the command again to run the program. And we see the output, Super Mario Bros. And then Pac-Man. We updated the value of the variable favorite game. Great, so now you know how to define a variable and how to update its value. Different types of values have different data types. And in Python we have many different data types that we can work with to write really powerful programs. So let's continue. In the next part we will talk about data types and how to work with them in Python. Great, so now let's talk about the different data types that you can work with in Python. Data types are just a way to describe the different types of values that you can store in a variable and that you can use in your Python programs. So let's define a variable called myVariable. And let's assign the value Python within quotation marks. In Python we have a function that we can use. A function is like a command that executes a particular functionality that you need. For example, type gives you the data type of a particular variable or value. After we find the type, we have to print it. So we write print and we surround type with parentheses. Okay, you can see that matching parentheses are displayed in the same color. Great, so let's run our file and now we can see that the type of that value is str. That is an abbreviation for string. Strings are used in Python to represent usually text or something that we want to treat as text, where that value is made by several individual characters that you can access individually or in slices. We will talk a lot more about strings in a coming part of the course, but I just want you to know that we have a particular data type to represent text. Great, so now let's write the value 7. What data type is the value 7? This value is an integer. In Python, the class int gives us that particular data type, integer. We use that to represent integers, including positive integers, negative integers, and the value 0. We can see that the negative integer is also an integer, and 0 is an integer too. Great! Now, if we write a decimal number with a dot, like 5.6, that changes the data type of the value. In this case, that would be a float. Float is a very peculiar way in programming of referring to a decimal number, because the point is not actually represented like this in memory. That is beyond the scope of the course, but if you would like to research more about floats and why they are called floats, that is a very interesting reading. Great, so then we find the value true. True and false. Let's check the data type of these truth values. The data type is bool. Why? Because these values are also referred to as booleans. Like this, booleans. Logic relies on these truth values, true and false. In Python, to write true and false, we need to write them with an uppercase letter. Else, if we write them in lowercase, we will see an error, because Python will not detect that we are trying to use those truth values. It will try to find a variable that is not defined. So with an uppercase letter and false here too, with an uppercase letter, and if we write it in lowercase, we will see an error. We saw booleans, we saw strings, integers, and floats. So now let's see another very, very helpful data type in Python, which is a data type, and it's also a data structure because it can store multiple values, a list. We will talk a lot more about these individual data types during the course. I just want you to know that they exist. If we use square brackets and we separate different elements with a comma and a space after the comma, we will get a list. Let's check that this is a list in Python. We see class list. Lists are very helpful in Python because they can be updated and they help us to store multiple elements in the same variable. They can be of different data types if you need to. If we change those square brackets with parentheses, then the data type is changed. Now we have a tuple. The difference between lists and tuples is that tuples can't be modified. So if we want to change this 2 with another value or another element, then we will get an error. So tuples are kind of safer in that way. You will not have any unexpected changes if you use a tuple and you want to keep those values fixed. We also have another data structure which is not so commonly used, but it's really nice to know that it exists, and that is called a set if we use curly braces around the elements. You can see that it's called a set. This data structure lets you store multiple values, but those values are not in any specific order. And it doesn't store any repeated elements. So if we write 2233, what we will store in memory will actually be this. It will remove any duplicate elements from the set. So sets are actually super helpful to remove duplicates from any list or tuple. And finally, we have the special value none. This is a particular value that will be very important when you start writing more complex programs. It basically represents the absence of a value. When the variable doesn't have a value yet, you can assign the value none in particular situations. And this is a value of the type none type. And last but not least, because it is super helpful, we have dictionaries. Let's say that I want to match two values. For example, Python in my program has to be associated to a particular value 10, and JavaScript is associated to the value 9. Like in Scrabble, different letters have different values for the final score. So that association, like in a dictionary we associate words with their definitions, can be achieved using a dictionary. In a dictionary we have curly braces, we have pairs of elements, and we can access the values through keys. You will learn more about dictionaries during the course, but let's check that this is actually a dictionary. It is, because right here we see class dict. Great! So now you have a general overview of these data types. So let's continue with the next part of the course. In the next part of the course, we will talk more about strings and how you can use them. So let's continue. Awesome, so now let's talk about strings. We will talk about each data type in more detail so you know how to work with them in Python. We will start with strings. Let's define a variable called myGoal. What is your goal? You want to learn Python. Let's work with that. Our goal will be a string. Strings can be defined with double quotes or with single quotes. Single quotes and double quotes will be almost equivalent. The only difference is when you have the other type of quote inside your string. For example, if I define my string with double quotes, let's close the Explorer. If I define my string with double quotes, and then I want to write this, I'm learning Python, that's okay because I used a different type of quote to define the string, and I have a single quote right here inside. So that's okay, it will work. But if I define the string with single quotes here, then that's an issue. That's an error that you will see in your program. Why? Python thinks that the string starts here and ends here. It basically finds the matching quote from start to end. So that will not work in this case. An alternative would be to add a backslash. The backslash is a character that allows us to escape special characters. So this will not be interpreted as a special character. It will be a normal character in the string. Since this is not so natural to read in our code, and we usually like to write code that is easy to understand, what we usually do is just use a different type of quote, and that will work correctly. You can find the length of a string. Let's go back to our original string, learn Python. That is your goal. So, with the length function, which is a function that Python already has, and that you can use anywhere you need to in your code, you can find the length of a string. The length of a string is how many characters the string has. In this case, we have 1, 2, 3, 4, 5, 6. Yes, spaces count too. 7, 8, 9, 10, 11, 12. So let's check this. My goal. And if we want to see that value, in the terminal we have to print it. During the course, you will see me printing a lot of these values, but you don't necessarily have to print them. You can use them in your program wherever you need to, and you can also assign them to variables, okay? I just print them so we can see them in the terminal. Right here, you can see the value 12. So that is the length of the string stored in my goal, learn Python. Strings also have sort of like an internal grid. Each character can be accessed with a particular integer called an index. That process of accessing the individual characters of a string is called indexing. Let's quickly create a diagram for this particular string. You will see me do this really fast, and we will see more details about this in just a moment. Here you can see this. I made a diagram of the string learn Python. In this diagram, we have the characters of the string, including the space right here, and integers that start from 0. These integers are called indices. One of these numbers is called an index. Indices are super helpful because if we use a particular index in a string, we can access its associated value. It's like saying, hey, give me the character at index 8, and the program will return that particular character, the letter T. We start counting from 0 because it's common in programming to start counting from 0. That is called zero-based numbering. Basically, you have to change the way you think about things when you start programming. Because initially, we might think that we always start from 1. But for indices, we start from 0. And that is something that you will get used to as you practice more and more with strings and with Python. So how can we access these characters? To access the character, you just write the name of the variable, my goal, and then within square brackets, you write the index of the character that you want to access. In this case, let's say that I want to access the first character. I would write the index 0 right here, and that would be replaced by the letter L in my program. My goal at index 0 is equivalent to the letter L. An uppercase L, like this. You might be curious about why we have some lines gray, shown in gray, and other ones have different colors. That is because these are comments in Python. In programming, we can write comments to explain what is happening in our code or the logic of our code for ourselves and for other developers. Right now, I am using comments to explain how strings work. But we will talk about comments later on in the course. I just want you to know what they are. They are lines in our code that Python will ignore. It will take them like, hey, this is a comment, so I don't have to run any code in these 2 lines. Comments are totally ignored and they're not considered as part of the code. Okay, so we can write anything we need to in those lines after we write the hash symbol. The hash symbol is what we use in Python to start writing a comment. Okay, so after this short parenthesis, let's go back to indexing. We are trying to access the first character in the string. Let's go to the terminal, let's run the program and see what we get. We get the letter L. Awesome, right? Exactly what we needed. Let's try this with index 1. This should return the letter E. So let's see. Now we see the letter E, exactly what we needed. So this is basically the logic of string indexing. Index 2 would be letter A, and so on. For all the different characters in the string, you can see them right here in the diagram. This is a challenge for you. Try to write all the remaining lines in the code to print all the remaining characters of the string. You just need to print the characters from index 3 to index 11. But that's good practice to help you familiarize yourself with the syntax of how you can index a string. Remember, the name of the variable, square brackets, and within the square brackets, the index. Awesome! Remember that we always start counting from 0, not 1. I have a special challenge for you right now. What will be printed if we use index 5? Think about it for a moment. If we use index 5, will this be an error? What character will this be? Great! Let's see what we get. A space. If we use index 5, we will get a space, because spaces and special characters are also part of that internal grid that you can use to work with strings. So that would be a space. If we have a special character, we can print that too. So let's delete this code and let's define a new variable called greeting. Let's say that we're greeting our friends or family and we say hello. Now we have a special character. Well, I'm referring to a special character as a character that is not a letter or a number. In this case, it's an exclamation mark. So if we write this particular diagram, we will see the indices. If we print greeting at index 5, let's see what we get. We get the exclamation mark. So these special characters are also treated as part of the string. They're part of that internal grid that you can see here, and they have their own particular index. And a really cool thing that you can also use in Python is negative indices. Negative indices start from -1 for the last character. And they go from right to left, like this. We start from -1 to the right, and we end with -6 to the left. And we are decrementing by 1 every time we move 1 place to the left. Usually we don't work with negative indices directly. What we commonly use is the negative index -1, because that will give us the last character in the string, regardless of its length. So it doesn't matter how many characters the string has, if you use -1, you will get the last character. And that should be, in this case, the exclamation mark. You can also take slices. Let's go back to my goal. What is your goal again? I want to learn Python, I'm learning Python, and I will learn Python. That is exactly what you have to say to get your mindset ready and your goal clear in your mind. We have that string and we can take a slice of that string. A slice is just a sequence of characters. Previously with indexing we were getting individual characters. Now we can get a slice, more than one character, if we need to. And that is very powerful. We just write the name of the variable, hello, my goal, and then we write where we want to start and where we want to end. Let's create the diagram again, and we can see the string and the indices. So let's say that we want to take a slice that goes from the letter P to the letter T. We want to get these 3 characters. What we would write is where we want to start, index 6, then a colon. Colons are very important in string slicing. And then we would write where we want to stop. But the character at the index that we write will not be included. If we want to include the letter T as the last character, we need to write the index of the letter H, 9. Just think of it like this. You want to write the index that will not be included, the first index that will not be included in the string. So we start from 6, we include 7 and 8, and then when we reach index 9, we stop. That's basically the logic. Let's see what we get. Let's kill the terminal and start with a new terminal. We get the slice PYT. Exactly what we predicted, PYT. Great. Now, we can also omit some of these values. If we want to start from the very first index in the string and we want to stop at a particular index, then we can just write the colon and the end index where we want to stop. Notice that we are not writing a number here, we're not writing 0 explicitly, because this is the default value if we omit it. We will start from 0 and then we will stop at 4. 4 is the index of the last character that we will include. Great, so let's see the output. We get the slice learn. See, we stopped at 4. Great. We can also start at a particular index and continue until we reach the end of the string. In that case, we just omit the second value and we write the colon after the first value. In this case, we're going to start from 6 and we're going to continue until we reach the value 11. See, we get the slice Python. Exactly what we wanted. And we can also customize this even further with 3 values, 3 parameters. We can say, I want to start from index 1 from E, and I want to stop at index 10. This will not be included. So the last one to be included should be H at index 9. But I also want to jump 2 indices before I add the next character. So I want to go from 1 to 3, from 3 to 5, from 5 to 7, and from 7 to 9. I want to add 2 to each index, to the current index. And all the other characters will not be included. This is like the step, how much we're going to jump from one character until we reach the next one in the slice. Let's see the result. We get this result. From 1 we jump to 3, from 3 we jump to 5, then to 7, and finally to 9 when we reach the letter H. Great, and one last string slicing tip is that if you write 2 colons and -1, you can get a reversed copy of the string, like this. Awesome, right? You get the same string, but reversed. And you can assign it to a variable if you need to. So now you learned more about string slicing, string indexing, and how you can get the length of a string. We also have very important string methods. One of them is capitalize. Methods are like functions that you can call, that you can execute to work with a particular value. In this case, that would be the string. You just write the name of the variable, followed by a dot and the name of the method. And then parentheses, empty parentheses if the method doesn't need any values, or some values if the method requires them. We will see different examples. Capitalize basically capitalizes the string if it's not already capitalized. Okay, so the first letter is in uppercase and the rest is in lowercase. Notice that this uppercase b was changed by a lowercase b. Then we have the method count. We can count how many times a particular character appears in the string. So let's count how many times this string has the letter N. 2. We have 2 letter N's and that is correct. So these are like common operations that the creators of Python have already implemented for us and they are super helpful. We also have a method to check if the string is alphabetic, if it only has letters, if it's alphanumeric, if it has letters and numbers, and we have many different options that we can use. Okay, we can check if the string represents a digit or if it's decimal. We can check if the string is in lowercase or in uppercase, and we can convert it to uppercase and to lowercase. For example, if we want to convert it to uppercase, we just call the upper method, and we get an uppercase copy of the string. Something very important about strings is that they are immutable. You can't replace a particular character in the string, like this. You can't do this. You can't replace the letter L with the letter P with the index. You can't do this, reassigning a particular character. If you try to do this, you will see an error. A type error. The string object does not support item assignment. Okay, so once you have the string, it will stay like that and you can't change it in your program. Great, so now you know more about strings and how to work with them in Python. In the next part, we will talk about another important and helpful feature in Python, taking user input to make your programs more interactive. So I will see you in the next part of the course. In Python, you can make your programs much more interactive by taking user input. Let's see how you can do that. You can ask the user to enter a value, and you can assign that value to a variable. For example, let's ask the user to enter his or her name. Your name. In Python, we have a built-in function that lets us read a string from the standard input. So the user can write a value, can enter a value, we will get that value, and we will store it or assign it to a variable. And we can use that variable in our program. The string that we write within the parentheses is optional. We can omit it if we don't want to show any message to the user. But it's usually very helpful to tell the user what you are expecting as input. For example, in this case, it's a name, but it could be a number. It could be a number in a particular range. So it's always super helpful. Let's take that name and print it to make sure that we are actually assigning it to a variable. Let's kill the previous terminal to start again, and let's run our program. You will see that the program stops at that particular line where you wrote input. Why? Because it's expecting input from the user. Where you see this little white bar, that is the prompt asking the user to enter a value. Enter your name. Let's say Nora. The user writes the value, presses enter, and then the program continues its normal execution. And in this case, we are printing the value of your name. So that is what we see here in the output. Great, right? That is very helpful when we want to take strings as user input. But what happens if we want to get a number? Let's see. Let's ask the user to enter a number. Let's rename the variable to your number. If you want to copy paste, those are the same keyboard shortcuts. Control-C for copying and Control-V for pasting. That can be super helpful too. So let's ask the user to enter a number. Let's see what we get. Enter a number. What will we enter? Let's say 8. Great, we have the number 8, but there's something that we're not seeing and that we will see if we write a program that has to work with a number. If we print the data type of the value that we got from the user input, let's see what we get. Look at this. We got the class string. So we are getting a string as user input, not a number. So this value will not have all the properties and functionality of a number in our program. It will be a string in our program. And that is not helpful because we can't add strings, not in the mathematical sense at least. We can't operate mathematically with a string. So how can we fix that? We just need to surround input with int. Int is a function that lets us convert a number or a string to an integer. Okay? In this case, we are going to take the string and we are going to convert it to an integer before we assign it to the variable your number. Now let's see what we get. We get class int. Awesome, right? So now we can work with that number as an integer, not a string. And we can use it for mathematical operations. Now you know how to take user input in Python. So now let's talk about Python operators and how you can perform different operations with this programming language. Operators are like the backbone of Python, because without them we couldn't really do much or perform more complex operations and write more powerful programs. So let's continue to operators. Awesome! So now let's talk about operators. Operators are symbols that have special functionality and meaning in a programming language. So they let us perform special operations or helpful operations in our program. We have several different types of operators. First, we're going to cover arithmetic operators. Arithmetic operators let us perform exactly that, arithmetic operations. Like in mathematics, we have addition, subtraction, multiplication, in this case it's the asterisk, division, the slash, and we also have floor division or integer division, 2 slashes, and we have a very powerful operator called modulo, which returns the remainder of a division. That is very helpful to determine if a value is even or odd. So let's see some examples. If we want to add 2 numbers, we just need to write the 2 numbers and the operator in between. Usually, for best practices to improve the readability of our code, we add spaces on both sides of the operator before the operands. These 2 values are technically called operands. Okay, so let's run the file, run the program, and we see the value 8. 5 plus 3. This is an example of an expression in Python. In programming, we have expressions which evaluate to a particular value, like in this case 5 plus 3, evaluated to the value 8. An expression is a combination of values and operators, and that results in a particular value. And we also have statements, which are instructions or actions to be performed. So those are like the 2 broad categories of things that you can find in a programming language. When we work with operators, usually we are working with expressions. The plus operator is kind of special because you can use it for more than just mathematical operations. You can also use it to combine or concatenate strings. If we write 2 strings and we want to combine them or concatenate them, we can just use the plus operator. Let's see. Let's save the file and run the program again. And now we see the 2 strings combined. But there is something very peculiar that we don't have a space in between. So we can add it separately right here. And we get the string with the words separated by a space. You can also store this final string in a variable. You can also work with the minus operator. This is more in the conventional mathematical way. That would be 2. The multiplication operator, that would be 15. The division operator, that would result in a decimal value. And that decimal value will be an approximation. 5 divided by 3. Like you can see right here, we have a finite number of decimals. So the last one is the result of rounding. And that can cause what we know as the floating point error. It is an error that is accumulated because decimal values are approximations of the real mathematical values. Because we have to represent them somehow in the computer, and we have limited space to represent them. So that is when the rounding error accumulates, and that's something that we have to be aware of, that when we're working with floats in programming, we're not actually working with the exact values. We're working with approximations. Great, if we use a double bar, let's delete this and just keep the first line. Let's see what happens. 1. Okay, instead of getting this result with the decimal values, the double slash, also called integer division or floor division, truncates the decimal part. So we only get the integer part, 1, if we are working with 2 integers. And finally, the modulo operator is the percentage symbol. This returns the remainder from dividing 5 by 3. In this case, it would be 2. 5 divided by 5, the remainder would be 0. 10 divided by 5, the remainder would be 0. Modulo is really helpful to determine if a value is even or not. If the value is evenly divisible by 2, so if the modulo is 0, then it is even. But if the result is 1, then it's not evenly divisible by 2, so it's odd. Awesome! Those are the arithmetic operators. Now, let's kill the terminal, and now let's go to comparison operators. Comparison operators let us compare different values. So we are talking about comparisons like greater than or equal to, less than or equal to, and not equal to. These are the comparison operators that we can use in Python. Remember, the exclamation mark and the equal sign is not equal to. So let's test this. Is 5 greater than 4? 5 is greater than 4, so the result was true. When we use comparison operators, the result will be a Boolean value, because the expression will evaluate to a Boolean value. We want to know if this is true or false. So the result will be either true or false. We can check if 5 is greater than or equal to 4. That is true as well. We can check if 5 is less than 4. Let me delete this. 5 is less than 4. That is false because 5 is not less than 4. Less than or equal to 4. False. Equal to 4. That is false. Is 5 equal to 5? Yes, it is. Is 5 not equal to 5? That is false. So that's basically the comparison operators. It's very important to know the difference between this and this. There's a very slight difference, but it's very, very important when you use it in practical applications in your code. If you use this operator and the two values are equal, then the result will be false. Because we're asking if this value is strictly less than this value. But if we add the equal sign, then we're asking if this value is less than or equal to this value. So that is like more open, more flexible. And it is true. So that can be the difference between having the correct code and a very serious bug. As a tip, the word bug is used in programming to refer to an error in the logic of your code. Okay, so if you ever hear the word bug, you know that it is talking about a problem with the code, an error that has to be fixed. The code works, but it doesn't do exactly what it's intended to do. So that is a bug. So now you know about comparison operators. Let's go to logical operators. Logical operators let us connect different truth values or determine if a condition is true or false. These operators are AND, OR, and NOT, and they have different truth tables. So let's see this practically in our code. Right now we're talking about the AND operator. I'm working directly with the truth values because in logic we have something called a truth table. A truth table is a table that lets us know when is going to be true or false. If we join two different conditions or two different expressions and they are both true, the entire expression will be true. If either one of them or both are false, then the entire expression will be false. Let's see the result and see if this initial intuition matches. Exactly what we got right here. The AND operator. True, false, false, and false. In practice, what we would usually write is the conditions that we are testing, that we are checking. For example, let's say that I have two variables, x equals 4 and y equals 2. Let's check if x is greater than 2 and y is less than 2. We can think of it like the coordinates of a player in a game. Let's say that we're developing a game. And we have the x coordinate, the horizontal coordinate, and we have the y coordinate, which is the vertical coordinate. Right here we have two conditions that we are checking. We're checking if x is greater than 2, and we're checking if y is less than 2. If those two conditions are true at the same time, and we connect them with the AND operator, then this entire expression will be true. This will be like the process behind the scenes. We take the entire expression, this is true, then this is true, and finally, since we know that true and true is true, this will be the final result. The truth values and conditions will be particularly helpful when we reach the part on conditionals. Conditionals are structures in our code that let us do certain things based on whether a condition is true or false. So we can create very powerful programs based on the state of our variables and the values of our variables in our code. For the OR operator, if either one of them is true, then the result will be true. The expression will evaluate to true. Let's see. Now, if we have x greater than 2, and this condition is true because we know that x is equal to 4, we know that this condition is true. So, the entire expression will evaluate to true. You can see it right here. Awesome. With the OR operator, if either one of them is true, then the result will be true. Let's test this in our code with the truth values like we did before. True or true, true or false, false or true, false or false. This will be true, and only when the two conditions are false, this will be false. So let's run our program and we see that this matches exactly what we have predicted right here. Okay, so you can always search for the truth tables of these logical operators. They're very helpful. And the NOT operator is even simpler because it basically reverses the truth value. Not true is false and not false is true, like this. It's basically reversing the truth value that we got here. If we have x greater than 4 and we define x as equal to 6, x is greater than 4 because it's 6. So this is true. You can see it more clearly, I think, if we add another set of parentheses. This will be not true, so it will be false. And with the same logic, we have not x less than 4. Not false is true. So that's basically how not works. It reverses the truth value. Awesome. And finally, we also have what we call assignment operators. Assignment operators let us assign a particular value to a variable. So far, we have been using the most basic assignment operator that we can use, the equal sign. One equal sign will assign the value to the variable. Just as a tip, it's very important to know the difference between one equal sign and two equal signs. This is a comparison operator, and this is an assignment operator. Only one equal sign tries to assign this value to this variable. But if we add two equal signs, then we are trying to compare the value of the variable with this value. So you have to be very careful and know exactly which one you want to use in which scenarios. So that's the most basic operator that we can use for assignment. But if we want to perform an operation before we actually assign the value to the variable, we can use what we call as compound assignment operators. If we define the variable with an initial value of 5, we can take the value, add 2 to the value, and then assign it to the variable. Initially, this may not be so intuitive, so let's break it down and see what it actually does. This is equivalent to this. We take the current value of the variable, which is 5, in this case, we add 2 to it, and then we assign that result, which would be 7, to the same variable again. We're basically updating the value based on its previous value. We take the value 5, its current value on this line, we update it by adding 2 to it, and then we assign it again to the same variable. So instead of writing this, which is much more elaborate, less compact, we can write it like this. We just take the operator and we write it before the equal sign. And that will take the current value, increment it or do the operation that we have right here with the value 2, and then assign it to the same variable. We can do that with addition, multiplication, subtraction, all the operators that you saw in the previous part of operators. So let's see what we get. Here we have the value 5. And here we should have the value 7. Let's see. Let's kill the terminal and start again. And voila, right here we see the value 5 and the value 7, exactly what we anticipated, based on this operator. But this is not the only compound assignment operator. It depends on the operation that you want to perform with your value. You can subtract 2, you can multiply by 2, you can divide by 2 before assigning the result again. You can perform all the arithmetic operations that we saw previously before assigning it to the variable again. And that's awesome. It's a really great way to write more compact and powerful code with assignment operators. Great! Now you know how to work with the different operators that you can work with in Python. There are other types of operators, but they are used less frequently. These are the most frequently used operators that you will need to work with Python. In the next video, we will talk a little bit more about comments in Python, and then we will start diving into more advanced concepts and data types. So, let's continue. During the course, we have been writing comments frequently, particularly when we talked about string indexing and string slicing. So let's talk a little bit more about comments, what they are, and why we use them in programming. A comment is a message or comment that you write in your code for yourself and for other developers to understand particular parts of your code. Usually we write them for more complex parts of the code or to clarify specific details that may not be so intuitive. Their job is to make our lives easier as developers. For example, let's write this variable. Let's define this variable. weight 45. In the program, we may see that variable and we may not know if that value represents a particular unit, like kilograms or pounds. How can we know that? Well, it could be written in a documentation, but we can also write it in a comment if we think that it's helpful for us and for other developers, because you may remember your thinking process and your logic right now. But in a few weeks or in a few months, when you go back to your code and see that again, you may not remember what you thought initially. So the comments can be super helpful. In Python, to start a comment, we write a hash symbol. From that symbol onwards, the line is interpreted as a comment. So it will not be considered as a real part of your code. It will not be executed by the Python interpreter. It will just be there in your file if you need to read it. And you can write it in any format that you need. It's usually recommended to add a space after the hash symbol for readability purposes. And you can also end with a period if you want to. You can also write multi-line comments in Python if you start each line with a hash symbol. Okay, but usually that type of comment is used to describe a more complex code block. Like, for example, in this case, we have, let me write an example. You should not know anything about this code yet. We will talk about this type of structure in programming during the course, but I just want you to know and realize what comments can do for you and for other developers. If you just see this code and you don't understand anything about the programming language, or you don't really understand what's going on there, then a comment can be super helpful for you and for other developers. Let's say that you just wrote this code, but you may forget the purpose of that code and the logic, what that code block does. So you can write a comment to explain it in your own words. This loop prints a triangle made with a sequence of asterisks. The triangle has 5 rows. Okay, so that's basically what the code does. And you wrote it and explained it in your own words, as if you were talking to a human. That is the purpose of a comment: talk to humans and to explain things. So don't ever be afraid to write a comment. But don't use comments too much in a way that will make your code more difficult to read. For example, let's say that I change this from kilograms to this represents weight. Well, this comment would not be really helpful because the name of the variable is self-explanatory. The name is weight, so we know that this value represents weight. If the comment doesn't add any additional information, or you think that it's not super helpful, then you can omit it. Okay, always assume that the developer will know how to read your code. Like, you don't have to write a comment like this. This assigns the value 45 to the variable weight. This is a comment that you should not write, because any developer who knows how to program in Python will know that this is assigning a value to a variable. So I would recommend omitting this type of comment. Only write comments that can have a value added for developers that are reading your code. Okay, so now you know more about comments. Let's continue with the next part of the course. In the next part, we will talk about lists, data types, or data structures that are built into Python and that are super helpful to store multiple elements. So let's continue. Now we will talk about a very helpful data type and built-in data structure in Python. A data structure is a structure in programming, in your programming language, that can help you to organize data and store it efficiently for a particular use case. In our case, we're going to talk about lists. Lists are very helpful to store multiple elements and to have the possibility to add them and modify them individually. You can also access the values. Let's define the variable favorite games. And let's create a list. We saw lists very briefly when we covered data types. So now let's define a list with the square brackets and let's include 3 strings: Scrabble, Monopoly, and Clue. The first thing that you can do with a list is getting its length, how many elements it has. You can do that just like with strings with the length function. You write length and within parentheses you pass the variable that contains the list. We're going to print this value, but you can also use it in your program directly. We see the value 3 because we have 3 strings in our list right now. Great, so now you know how to get the length. You can also index a list. To index a list, you need to use indices, just like we use them with strings. But now instead of individual characters, we're going to get the individual elements of the list, the values that we are storing in that data structure. Each element will have an index associated to it. Scrabble will have the index 0, Monopoly index 1, and Clue index 2. So you can see that again, we start to count from 0. That's really awesome, right? So now let's print each individual element so we can practice how to access those elements. Like with strings, we write the name of the variable and within square brackets, we write the index. So this should be Scrabble at index 0, then favorite games, 1, this should be Monopoly, and then this should be Clue. Let's run our code. Scrabble, Monopoly, and Clue, exactly what we needed. And we use the indices to access the corresponding elements. Awesome! We can also use negative indices. So if we need to get the last value, we would just write -1. This would be -2 and this would be -3. So that would give us Clue, the last element in the list, with index -1. Then we can also use slicing when we work with lists. Just like with strings, if we want to get a particular slice of the list, multiple elements, that will create a new list and return it to us so we can store it in a variable or use it in the program. Let's say that I want to get a slice that starts at index 1 and includes all the elements until it reaches the end of the list. In this case, we only have 3 elements, but this would start at Monopoly and include all the elements until the end. So let's see the result. That is Monopoly and Clue. Exactly what we expected. It's the same principle that we used with strings. You can have 2, 1, or 3 parameters, and you can also use their default values. Okay, you can omit them to include everything from that index to the end or from start to that index. Here, we are going to get everything from the start, from index 0 up to index 2 without including it. So that would be Scrabble and Monopoly. Awesome. Now, if we want to get all the elements, but we want a step of 2, so we want to include every other element in the list, we write it like this and we get Scrabble, we skip Monopoly, and then we go to Clue. If we write 2 columns, we're saying that this will be the step, how much we're going to jump from one index to the next. And if we want to reverse the list, we just write -1. Like this, Clue, Monopoly, and Scrabble. It reversed the order of the elements in the list. Great! You can also update an element of the list. So if you want to replace Monopoly with Uno, a famous card game, then you can do so. Favorite games, you write square brackets, the index, Monopoly is at index 1, and then you assign the new element. In this case, another string with the word Uno. Favorite games. Let's see the new value of the list. you can see that now, instead of Monopoly, we have the game Uno at index 1, so it was replaced. We also have some list methods that are super helpful to perform common functionality, like adding an element, removing an element, and all of those operations. We can add elements to a list. If we want to add an element right here after clue, as the last element of the list, we can use the append method, like this. We write the name of the list where we want to add that element, then we write a dot, and after that we write the name of the method, append. In this case, let's append the game Space Invaders. Great, let's save our file, and now let's print the list, favorite games. Let's open up the terminal and see what we get. If we open the terminal, then we can run the command python followed by program.py. And now we see this result: Scrabble, Monopoly, Clue, and at the end of the list we have Space Invaders. Awesome, right? We just added our first element to a list. Append is used exclusively to add the element at the end of the list. So when we call the append method, this new element will be added right here after clue as the last element. But we also have the possibility of inserting the element at a specific index. And for that, we use the insert method. Let's try this with a different example. Let's say that I want to insert at index 2 the game tic-tac-toe. This is index 0, this is index 1. So at index 2, where clue is right now, we would have tic-tac-toe. Okay, great. So let's see how insert works. You can write the index where you want to insert it. In this case, 2 would be before clue, and what you want to insert, in this case, tic-tac-toe. So let's see the output, and we see tic-tac-toe at index 2. Clue was just moved one index to the right. Now, if we want to get the index of a particular element, let's say Monopoly, we can get the index with the index method. We just need to print that value because this will return a number, the index. 1. Monopoly is at index 1, and that is correct. Then to remove an element, let's see how this works. We have the pop method. Pop removes and returns the item at the last index by default. Okay, so it should remove and return the value clue. It returns it so we can use it in our program if we need to after we remove it. Let's see. Now we see Scrabble and Monopoly. Clue was removed when we printed right here after calling pop. Awesome, now let's check another method called remove. Remove is similar to pop, but instead of deleting an element at a specific index, it removes a particular element from the list. So if we want to remove Scrabble, then we write Scrabble within parentheses with the remove method. Like this. Now we only have Monopoly and Clue. We can also reverse a list, and this will cause permanent change on the list, okay? It will reverse it in memory, and you can see that the order was completely reversed. Now Clue is first and Scrabble is last. We can also sort it by default alphabetically, okay, with the sort method. Clue, Monopoly, and Scrabble. And you can customize how to sort it. You can learn more about this customized sorting process in the Python documentation, but it's really awesome and powerful. And finally, you can remove all the elements from the list with the clear method. You can see that after we call clear, we have an empty list. Awesome, now you know how to work with lists in Python. You have the fundamental knowledge of this powerful data structure. Next, we will see a very similar data structure that has a key difference: tuples. We will talk about them in the next part of the course. So let's continue. Okay, so let's start talking about tuples and how and why they are different from lists. Let's create a tuple of programming languages. Remember that tuples are defined with parentheses. If you see parentheses, that's a tuple. If you see square brackets, that's a list. So let's define this list with Python, JavaScript, C#, Swift, and Java. These are all different programming languages with different applications. The first thing that you can do with a tuple is find its length, just like with a list or a string. In general, when you have a data structure with multiple elements, usually you can find the length of that data structure. So we do the same thing that we did with strings and lists. And we see its length, 5. Okay, so that's awesome. We can get the length. And now let's see the main difference between lists and tuples, because so far they look very similar. With lists, we were able to update particular elements at particular indices, right? So in a list, if we wanted to replace JavaScript with Kotlin, for example, another programming language, that would work. But in a tuple, if we try to do this, if we try to replace the element at index 1 with Kotlin, for example, let's see what happens. We get a type error. Tuple object does not support item assignment. We can't modify the elements in a tuple. We can't reassign them. And that is because tuples are immutable. That is a very important term in programming. Mutable data structures and immutable data structures or objects. Mutable means that they can be updated and changed, and immutable means that they cannot be changed. A tuple is an immutable data structure, so you can't update its elements. What we can do with tuples is to access their values through the same process that we used called indexing. Let's do this with tuples. It's the same principle that we used with strings and lists. We have indices. Indices start from 0, then they are incremented by 1 as we move to the right, and they reach the last element. We can also use negative indices. Let's access the first element, and let's copy and paste this to access all the elements, 2, 3, and 4. Let's kill the terminal and start over. We see each programming language on a different line, okay? Python, JavaScript, C#, Swift, and Java. Awesome. Let's experiment a little bit with slicing, because we can slice a tuple. Why are we able to slice it? Well, because slicing returns a copy of the tuple. We're not actually modifying the tuple since it's immutable. We're getting a copy with only the elements that we are requesting through these numbers. So let's say that I want to get a slice from 1 to 3 inclusive. I would write 1 here as the start parameter and then 4. Because remember that the element at this index will not be included. The result will be JavaScript, C#, and Swift, exactly what we got here. Now, if we add a step, the value 2 right here, let's see what changes. Remember that we have to save the file before we run it to see the changes. JavaScript and Swift. Now we are including every other element, so we skipped C#. Great, so now let's take a slice that starts from index 2 and goes until the end of the tuple. We see C#, Swift, and Java. Awesome, right? All the same principles apply. If you want to get a reversed copy of the tuple, you write 2 colons and -1. Like you can see, the order was completely reversed. But it's also important to know that we are getting tuples as the return values. And when we did this with lists, we got lists. So we are keeping the same data type. Great, and for tuples, we also have very helpful methods. We have fewer methods because we can't actually mutate them, but the ones we have are pretty helpful. Let's define a new tuple called myTuple. And for the sake of this example, I am going to repeat the string hello 3 times because we will be counting occurrences. Now I write myTuple, and we have a count method that you can use. Let's count how many times the hello string appears in the tuple. And let's also count how many times we have world. We have to surround this with print to see the output. So let's run the program, and now we see 3 and 1. We have hello 3 times, and we have world 1 time. So that's a very helpful method, count. And we also have index. Let's test this. Index will return the index of the first occurrence found in the tuple from left to right. So in this case, the first occurrence of hello is 0, and the first occurrence of world is 3. Remember that we start counting indices from 0. So here we see 0 and 3, exactly what we expected. And those are the main characteristics, functionality, and methods that you can use to work with tuples in Python. They are really awesome data structures that can help you to write very powerful programs. In the next part, we will talk about dictionaries. Dictionaries are also super helpful, and they are used for very different use cases. So let's see what they're all about in the next part of the course. I will see you there. Great, so now we've reached the part where we will talk about dictionaries. Dictionaries are the last data structure that we will talk about in detail during the course. Why? Because they are very important in use cases where you want to associate two values, where you want to keep pairs of values associated. For example, let's say that I want to associate chemical elements to their symbols. What I would do is I would define a variable and assign a dictionary. We define dictionaries with curly braces, also called curly brackets. And within the dictionary, we write key value pairs. We're going to associate a key to a value. The key is the value that we will use to refer to the value. Let me explain this with a more concrete example. The chemical element hydrogen has the particular symbol H. If we want to access the symbol of hydrogen, we will write in a particular way hydrogen, and then we will get access to its value. It's like in a dictionary. We use the word to get the definition. But in this case, we are using a particular key to get a particular value. We separate the key from the value with a colon and a space after the colon. And we separate key value pairs with a comma. Let's write more key value pairs. Boron, sodium, potassium, and iron. Okay, so we have a list of chemical elements and their symbols. So if we want to get the chemical symbol of hydrogen, what we would do is we would write the name of the dictionary, and within square brackets, like we used to write the indices, now instead of the index, we will write the corresponding key. So we're asking to get the value of hydrogen in the dictionary chemical symbols. And that will evaluate to this particular value associated to hydrogen. Now let's print this value and see what we get. We see the letter H because that was the symbol associated to hydrogen. Awesome work. Now let's test this with another key, sodium. We see the corresponding symbol. There is an important characteristic for the keys. They have to be of an immutable data type. So they can be numbers, they can be strings, they can be tuples, but they cannot be lists. They cannot be mutable, and they have to be unique. You can only have one hydrogen key in the dictionary, because otherwise the program would not be able to find that correct value. Now you know how to access the values of a dictionary. You can also find the length of a dictionary with the length function. That will give you the number of key value pairs. Okay? The number of pairs that you have in the dictionary. 5 in this case. And that is correct. We have 1, 2, 3, 4, 5 pairs. That is correct. Now let's see how you can add a key value pair. To add a key value pair, you just need to write the name of the dictionary, chemical symbols, then the string within square brackets. This will be the new key of the key value pair, and then you write the value. CN, in this case for zinc. Okay, so after we add the new key value pair, we can print the dictionary to see the changes. Chemical symbols. We can see the dictionary right here, and you can see the new key value pair, zinc, associated to the particular value CN. So that worked. Awesome, right? If the key is not new in the dictionary, if it already exists, then its value will be updated. Let's say that boron will no longer be B. It will be BOR. Just as an example, a hypothetical example, I know this will never change, but just for showing you how you can update the key value pair, then you would just write the existing key here and the new value. And that will update the value associated to the existing key, like this. Now boron is associated to the string BOR, bor. Great! You can also delete a key value pair, like this. You write del, this is a statement, del is a keyword, and then you write the name of the dictionary and the key that you want to delete. That will delete the key value pair. Okay, so if you delete it with the key, that will also delete the value. Then, after we delete that, let's print the dictionary. You can see that we deleted iron from the dictionary, and now we don't see it in the output because it was deleted successfully. We also have some helpful dictionary methods, like, for example, let's check this out. We write the dictionary, and then we can also get the value associated to a particular key with the get method, hydrogen. We can also remove a particular key value pair with the pop method. That is another option. Let's say that we want to remove boron. Another option is to call the pop item method, which deletes the last inserted key value pair. Let's see these 3 methods in action. First, we have to print the dictionary. And here we have to print to see the value. So let's run the program. We get the value associated to hydrogen. Then we pop boron, so we don't see it right here. And then we pop the last key value pair that was inserted. So now we see only hydrogen, sodium, and potassium. So iron was removed and boron was removed. We also have a method, clear, that removes all the key value pairs. So if we run it again, we can see the dictionary that is empty. And we can also update the dictionary with another dictionary to update multiple key value pairs at the same time. Let's say that the organization decided to change these symbols. Now we see that hydrogen was updated and iron was updated. So this is a cool way to do this on the same line. Great, so now you know how to work with dictionaries in Python. These are all the fundamental operations and characteristics that you need to know about a dictionary to start working with them in Python. In the next part of the course, we will start talking about conditionals. They are very important. Branching and conditionals let us write very powerful programs. So I will see you there. Okay, so now that we covered the main data types and data structures that you can use in Python, we will start talking about other very important topics and fundamentals in programming, particularly conditionals, loops, and functions. So let's start with conditionals. A conditional is a structure in programming that lets you define what should happen in your program based on whether a condition is true or false. So if the condition is true, you can do something, but if it's false, you can do something entirely different if you need to. That kind of logic that you add to your program is very powerful because you can create programs that depend on the particular value of a variable. Let's see an example. Let's define a variable called score. We're developing a video game, and we have a variable called score. If the score when the player ends the game is greater than 80, then we are going to print congratulations, you won. Okay, but if the score is not greater than 80, then we will not print anything. And here we have several different concepts combined, and something entirely new that we haven't seen so far, at least not formally. Indentation. In an if statement, we write the keyword if followed by the condition. This is the condition that Python will evaluate to determine if this particular line of code should be executed. We can have multiple lines here below print. If this condition is true, this code will run. But if it's false, then the code will not run. This is when the power of Boolean values and comparison operators starts to come into play to combine and create powerful programs. We have the operator, we have truth values, we have expressions, and we have functions, all combined. And we also have something new. We have a colon right here at the end of the first line, and we have 4 spaces before the line, before print. The colon at the end of the first line is required in Python when you write compound statements. Compound statements have a header, which is like the first line where you set up everything, and then they have a body. The body, in this case, will only run if the condition is true. And the body of the conditional has to be indented. In Python, we indent the code with 4 spaces per level. If we write it like this, we will see an error, because the line will not be considered as part of the conditional. We have to add 4 spaces for the error to go away. That is what we call indentation. And in Python, indentation is required. It's not just for style or for readability. It is functionally required to run your program and to write it correctly. Okay, so let's save our file and let's run our code and see how it works. We don't see any output. Why? Because the condition was false. The value of score is 56. So when we reach this line, the score is not greater than 80. So this condition is false. This code never runs. Now let's change this to 94, for example. Now we see congratulations, you won, because the value of score when we reach this line was greater than 80. Awesome, that's basically the logic of an if statement. This is what we call the conditional with this particular syntax, an if statement. We can also have other types of conditionals. So let's say, for example, let's define a variable and we can check if the name is equal to Gino. If that is the case, we will say, hi Gino. In this case, since this condition was true, the 2 strings were equal, then we can say hi Gino. But if the name is Nora, then we don't see any output because this line never runs. That is the most basic form of an if statement. We can also add another clause called else. Let's see. Right now we're telling the program what should happen if the condition is true. But we also have the power to tell the program what happens if the condition is false. And that is what we do when we write else. You can see how we are expanding the conditional gradually. When we add the else clause, we are saying if this condition is true, then run this code. Else, if the condition is false, then run this code. We can have multiple lines inside the body of if and inside the body of else, okay? We don't have to write just one line. It can be as complex as we need to. This is just to illustrate the logic of how this works. So let's see how it works now that we know that the name is not Gina. Previously, we saw no output. Let's run the program, and now we see this. Hey, your name is not Gina. So this code runs because this condition was false. That's basically the logic of the if-else statement. If this condition is true, run this code. Else, if it was false, then run this code. And that is very powerful. And you can also expand it even further with an elif clause. The elif clause lets you test multiple conditions. Let's see this. Let's define the variable x equal to 6. And let's say if the value of x is greater than 3, then we are going to print hello world. If the value of x is greater than 0 but less than 3, then we're going to print Python is awesome. Else, we're going to print have an awesome day. So we're giving the program 3 different options of what it should do based on these conditions. If x is greater than 3, then it should print this message. Else, if it's not greater than 3, but if it is greater than 0, then we print this message. Else, if these 2 conditions were false, then have an awesome day. Let's see what we get with the value 6. We see hello world, because x is greater than 3. It's 6 right now. Now let's choose the value 2. Now we see Python is awesome. Why? Because x was not greater than 3. So this condition was false. Python checked the second condition. Now this was true because x was greater than 0 and this code was executed. And now let's have a negative number. So neither one of these conditions will be true. Now we see have an awesome day. Because the value was not greater than 3, it was not greater than 0, so we went to the backup clause, which is else. If none of the previous conditions were true, then we go to else and we run this code. That is basically the logic of a conditional, okay? And you can have as many elif clauses as you need to, but there are certain rules. The if statement has to be at the very top of this sequence. This is the first keyword that you should have in a conditional. Then the elif clauses should be in the middle. And then if you need to, you can write an else clause. It is not mandatory, you don't have to write the else clause all the time. But if you need to, it has to be at the end. Okay, so these are just some basic rules. Now you know how to work with conditionals. Next, we're going to talk about loops. Loops are also very important because they let us repeat code blocks in our program. So, let's continue. Awesome, so now we will start talking about for loops. What is a loop? A loop is a structure or a tool in programming that we can use to repeat a sequence of lines of code. So we can repeat a code block as many times as we need to. We have 2 types of loops, for loops and while loops. Let's talk about for loops first. This is an example of a for loop. For loops can use range or not. We will see the 2 different variations. We write the keyword for, then we write the name of a variable. This variable is called the loop variable, and it will be updated automatically as we repeat our code. Then we write the keyword in, and then we find range. Range will return a sequence of integers that will be used during the iterations. In programming, an iteration is just a repetition of the code. Then we find a colon. The colon is here because we are using a compound statement like we used in conditionals. They have to be there, otherwise you will have a syntax error like you can see right here. It says that it expected the colon. Then we have indentation, because loops have a header and a body. And for a line of code to belong to the loop, it has to be indented. If we write it here, we will see an error because it's not part of the loop. Okay, so after we have that, we can see the output. Let's see what we get. Let's kill the terminal from the previous output and let's run the program again. We see 0, 1, 2, 3. Why do we see that? We are running print 4 times. When we write the loop, the body of the loop will be repeated as many times as we set up in the header. Why are we looping 4 times? Well, because range, when you pass the value 4 to range, this function will return a sequence of values 0, 1, 2, and 3. By default, the sequence will start from 0. Yes, again, we start counting from 0 just like we did with indices. And we stop at 3. 1 less than the number that we passed here. These values will be assigned one by one to the loop variable. And we can use that variable inside our loop, inside the body of the loop, if we need to. It's not necessary, we can just print a value or do whatever we need, but usually we use it, and we update this value. First, the value 0 will be assigned to I, then the value 1, and then the value 2, and then the value 3. And each time, the body of the loop will be executed with the updated value of I. That is why we see 0, 1, 2, and 3 in the output. We print 0, we print 1, 2, and 3. And just to show you that it's not necessary to use the loop variable, let's print hello world. But you will see that the result prints hello world 4 times because we had 4 iterations. In the loop, you can do more complex things too. Let's say that you want to update a variable. Like here, you want to print the value of x, and you want to increment x by 1 in each iteration. You print the value, you increment it by 1. Here you can see that. We start at 5, we increment it by 1, and we stop after the 4th iteration. So in the for loop, we are determining how many iterations we will have. And we are doing that with range. That is why we typically use range in for loops in Python. Right now we're starting from 0, but we don't necessarily have to start from 0. We can start from any number that we need. For example, let's change this to 2 and let's end at the value 8 without including it. So the last value will be 7. Let's change this loop. This call to range will return the following sequence: 2, 3, 4, 5, 6, and 7. So we should see the output with these values, because they will be assigned to the variable I one by one per iteration. Let's see the output. From 2 to 7. Exactly what we predicted. So we can use 2 parameters. And we can also use 3 parameters. Let's say that we want to increment the values by 2 instead of 1. To go from 2 to 4, from 4 to 6, and from 6 to 8. But since 8 will not be included, the last value should be 6. That is when we add 2 as a step. Exactly what we anticipated, 2, 4, and 6. Great! We can also iterate over a sequence. For example, if we have a list of favorite colors, blue, purple, and green, we can use a loop to do something with each one of those elements. We say, for each color in my list of favorite colors, I will print that color in the terminal. Notice that here we are not writing I. I and J are usually used when we are working with range because we will have integers. But when we iterate directly over a list or a tuple or a dictionary, we usually write descriptive variable names here. So if this is a list of colors, the variable will be a color. Okay, so we see blue, purple, and green, one by one. And we can work with these values. We don't necessarily just have to print them. When you start writing more complex programs, you will start to see how loops are super powerful. And we can also iterate over the elements of a dictionary. Let's write our chemical symbols again. We have our chemical symbols here, and let's say that we want to do something with each key and its corresponding value. So for every element and every symbol in chemical symbols.items returns a sequence with the matching keys and values from the dictionary. So we can iterate over them and work with them simultaneously. Element and symbol. Yes, we can define more than one loop variable if we separate them with a comma and a space before the in keyword. So in this case, we can do that because items will return a sequence with two matching values or two associated values, element and symbol. And we can work with them simultaneously in the same iteration. Like this, hydrogen with its corresponding symbol and so on for every chemical symbol. Great, so now you know the fundamentals of for loops and how you can work with them. You can learn more about the range function and all its variations in the official Python documentation. So now, let's continue and let's see a few examples of the other type of loop that we can use, while loops. Now let's talk about while loops. While loops are a bit different from for loops because in a for loop, we already know in advance how many iterations we will have, how many times the code will be repeated. But when we don't know that, and we only have a condition that is necessary to stop the process, then that is when we need to use a while loop. Let's say that I have a variable x equal 4. And while x is less than 15, I want to print the value of x and I want to increment the value of x by 2. In this case, I am writing a while loop that will only stop when x is greater than or equal to 15. I say, while this condition is true, do this. We don't have a particular number of iterations, okay? That's the key aspect of a while loop. It basically depends on the condition, only on the condition. When this condition is false, the process or the repetitions will stop. Let's see the results. We start with the value 4, we increment it by 2, and we only stop after we reach the value 14. We increment it to 16, and now the condition is false and we don't have another iteration. So that's basically the logic of a while loop. It's very common to use a while loop when we are working with user input, because we don't know how many times the user will want to play a game or do something if the program is interactive. So for example, let's define a variable called stop. There are other ways to do this, but I'm just writing this to illustrate how while loops work, okay? Well, we shouldn't stop. While stop is false, we want to print hello world and we want to take user input. Would you like to stop? Enter Y for yes and for no. If the answer is yes, then we are going to set stop to true. So if stop is true, remember the not operator. This is a logical operator that reverses the truth value. So if this is true, this will be false. And the while loop will stop. So let's run our code and see this. Would you like to stop? Enter yes or no. I don't want to stop, don't want to stop. So since we don't know how many times we will have to repeat the hello world line, we are using a while loop. And then when the user enters Y, we stop and the program ends. So I hope this illustrates the principle of a while loop. We couldn't have done this with a for loop, because in a for loop you have to specifically set the number of iterations that you want to run. In a while loop we do have a risk that we don't have with a for loop, the risk of an infinite loop. That is a loop that will run continuously. In theory, will never stop until you stop it manually, or the system stops the loop. Let's say that I have a variable x equals 6, and while x is greater than 2, I want to print the value of x and I want to increment the value by 2. You can see that the process never stops. You can only stop it with Control C. Or in Mac, that should be Command C. And you will see keyboard interrupt. Why? Why did this happen? Well, because the condition was never false. We start with the value 6, and then we increment it by 2. So the condition x greater than 2 will always be true. It will never be false. The process will continue in an endless loop, in an infinite loop, until we stop it manually or the computer stops it. So now you know the fundamentals of loops. You know for loops and while loops and their key differences. Great work. In the next part of the course, we will talk about functions. Functions are also very important because they help you to write reusable and readable code. So I will see you in the next part. And now let's dive into functions. Functions are very helpful in programming because we can write code that we can reuse throughout our program. And that is one of the main principles in programming. Do not repeat yourself. If you can avoid any repetition, that is recommended because your code will be easier to read, easier to maintain, and it will be less error prone. Okay, so let's start talking about functions. How can you define a function? A function is basically a code block with special characteristics that we can reuse in our program, and we can send information from the main program to the function and from the function to the main program. They're like small compartments of our main program that have their own unique characteristics, and variables that are defined inside a particular function can only be used within that function. Okay, so let's define our first function. First, we write def. That is a keyword that we use in Python to define a function. Then we write the name of the function, how we will call the function from the main program. Usually that is a verb or a descriptive name that says exactly what the function will do. In this case, our function will be called say hi. What will the function do? We define that inside the body of the function. Again, we are indenting the body of the function like we did with conditionals and loops. And in the first line, we are defining the header, the function header. And this is the body. In this case, you may not see all the benefits of defining a function because we are only writing one line here. But if we had 5, 10, 20, or even 50 lines of code, then we would be avoiding repetition. And that can be super helpful. Now, if we go back to our main program, notice that right now we are not indenting the line, so it's not part of the function definition. And we call it with parentheses. To call a function, we write parentheses after its name. We see hi as the output. Okay? Then we can call it multiple times, like this, and we use that line of code that we defined in the body of the function. That way, whenever we call the function, we will be printing hi. Exactly what we were looking for, reducing repetition. A function can also take values from the main program to customize how it works. For example, a name. Let's say that we want the function to be able to customize the message and mention the name of the person. So we just write name within parentheses, and that is what we call a parameter. Functions can take parameters. Those are values that they can receive when they are called. Remember when we called methods and other functions that already came built in with Python? Sometimes we passed some values to them. Those were called arguments. And those arguments have their corresponding parameters in the function definition. So we pass values to them, and they are replaced. Those values are replaced wherever they appear in the function. So if we pass the name Gina, when the function runs, this value will be replaced by Gina. If you're curious about why I'm writing the string like this, well, it's an F string. In Python, if we add an F before the string, we can write curly braces to replace the value of a variable in the string, so it's more readable. Let's see how this works. Let's add an exclamation mark. We are passing the name, the value Gino, to that particular parameter. This is the argument, and this is the parameter. The parameter is sort of like creating a template of where we want the value, the argument, to be replaced when we call the function. Everywhere where we use a parameter, we will be using the actual value that we passed to the function. So if we call the function again with Nora instead of Gino, we will be replacing Nora here. And that is super powerful because we can avoid repetition and create a general template of what should happen when we call the function with a particular value. Let's see. We see hi Gino and hi Nora. Like you can see, the arguments were assigned to the parameter and they were replaced wherever we used the parameter in the function definition. We can also have multiple parameters. Let's see this example of a function that will multiply two values, a and b. Here we are defining two parameters, a and b. And the function will print the result of multiplying a and b. Now let's multiply 3 and 6. And let's also multiply 8 and 2. And let's also multiply 2 and 9. We are reusing this line of code by calling the function multiple times. Let's check the results. We see 3 times 6, which is 18, 8 times 2, which is 16, and 2 times 9, which is 18. So the function is working correctly. It is printing exactly what we need to the terminal. And it is assigning the corresponding arguments to the parameters. The first argument will be assigned to the first parameter, and the second argument will be assigned to the second parameter. Okay, so they are assigned in their corresponding order. That is a key feature of arguments and parameters. Now, let's see an example of a more complex function, more than one line. This is a function that will count how many vowels a string has. It will take one parameter called word. Inside the function, we will define a variable called number of vowels. Initially, this variable will have the value 0. This will be a local variable. If we try to access that variable outside the function, it will not work. But if we define a variable in our main program, that variable will be available inside the function because it will be global. Now let's have a for loop. For each character in the word, in the string, if the character is in this string, this is another operator that you can use to check if an element is in a sequence, in this case in a string. These are the vowels. Then we are going to increment the value of the number of vowels counter by 1. And then we are going to print the number of vowels variable. Notice that right now we are writing print at the same level of indentation as the keyword for, because we are not trying to print this multiple times. This line will not be part of the for loop. So if we don't want the line to be part of the for loop, we write it at the same level of indentation as the keyword for. You can see how we are using indentation to separate the different lines or blocks of code. Here we have the for loop, and inside the for loop we have a conditional. And inside the conditional we have this line. Awesome, right? In Python, indentation is super important. So let's call this function count vowels to count the number of vowels in the string programming. And let's count it again in Python and again in coding. And let's run the code to see how it works. We see 3, 1, and 2. This is the number of vowels in each one of these strings. I hope this example illustrates the importance of functions in programming. You can see how we wrote 5 lines just once and we reused them 3 times. That would be 15 lines of repetition in our code. Instead, we are creating or defining a function and we are reusing it with the word parameter. Each one of these strings is passed as an argument and assigned to the parameter word. And then the same general process is applied to all the strings. Another great thing about functions is that you can return values from the functions. Just like we can pass a value to a function, we can return a value from the function. Let's say that instead of print, we want to return the number of vowels. Why are we going to do this? Let's see. For now, let's keep the call to print. If we only print the value of number of vowels, let's see what happens if we try to assign the result of calling the function to a variable. Let's see what value we get. We get the value none. Okay? So basically, we're not getting any value from the function. By default, when a function doesn't return a value explicitly, you will get the value none. Remember that this is a special value in Python. So, if we want to return that value, that result, so we can assign it to a variable, instead of printing it, we need to return it. Now, if we run the program, we see the value 1. Because the result was returned, we assigned it to a variable, and then we can use the variable in our program. That's the difference between printing the value and returning it. When we return it, we can use it in the program and we can assign it to a variable. So that's super helpful too. Great, so now you know the fundamentals of functions in Python. We also saw parameters and arguments and the return statement. These are very powerful concepts that can be applied to any programming language. Next, we will see a little bit more about the Python documentation and how you can expand your knowledge by browsing the documentation. So I will see you in the next part of the course, so let's continue. The official Python documentation is a really great place to find more information about Python. I use it all the time, and developers refer to the official documentation as they work in their projects and programs. So, what you need to do is just go to the official Python website, python.org, and then go to documentation. Then select Python Docs. That will take you to the documentation. Make sure that you are in the correct version. You can change your version here in the drop-down menu. And you can also change your language. The documentation is a really broad set of articles. Usually, what you will reference the most is the language reference. And particularly, you can find many different things about the language. You can find more about expressions, about operators, about statements, about compound statements like the if statement, the while statement, the for loop. You can find many different things that we saw during the course. And you can also find information about built-in functions. That is super important. You can also find a glossary. Here in the glossary, you can find important terminology. Right here, you can also search for things. If you click on Go, you will find quick search results. And another part of the documentation that you should keep under your pillow that is correct, because you will be referencing very often, is the library reference. Particularly built-in functions. Built-in functions is a very helpful article. You can find more information about the built-in functions that you can use in Python. For example, let's click on length. We use this function several times. It returns the length, the number of items of an object. And you can find more details about its implementation. Another helpful article is built-in types. You can find more information about the Boolean operations, about comparisons, about numeric types, and about many different built-in types that you can work with in Python. If you want to share a link to a particular part of the documentation, you just click here on this symbol and you create a permalink to this headline. You can see it right here, and then you can copy paste it so the person that you are talking to or explaining something to can reach that particular part of the documentation much more quickly. Great! So that completes our Python course. I hope you like it. It's been great having you here. I invite you to subscribe and to like this course if you found it helpful. So thank you. Have an awesome day.